MLOps Engineer and ML Engineer sound almost identical, but one you can realistically self-teach, the other one you probably cannot. By the end of this video, you'll know exactly which path makes sense for you, because too many people spend months grinding through deep learning courses and then apply for jobs and get destroyed by candidates with PhDs. So let me break down the real differences so you can make the right call. Let's start with what you're actually up against. Only 3% of ML engineer job postings are entry level, and over a third of those postings, 36% to be exact, list PhD as preferred, and that number is seemingly going up and not down. When you apply for an ML engineer role, you're competing against people who might have spent 5+ years in academia, publishing research papers, people who can derive backpropagation maybe from scratch on a whiteboard, and people with recommendation letters from professors that hiring managers might even recognize. So is it impossible to self-teach ML engineering? No, neither of PyTorch's co-creators had a PhD, but for every self-taught ML engineer who made it, there are hundreds who didn't. I would say it's survivorship bias. MLOps engineers, on the other hand, play a completely different game. MLOps is essentially DevOps plus machine learning knowledge, and DevOps has been proven self-teachable by thousands of engineers over the past decade. In this case, you're not competing against PhDs, you're competing against other software engineers who learned the same way you're learning. Through YouTube, through courses, through building projects. And the skills transfer directly. If you know Docker, you are already part of the way there. If you understand CI/CD pipelines, cloud platforms, and infrastructure as code, you just need to add the ML specific pieces on top. Most MLOps engineers come from a software development background rather than a data science background. And these are very often self-taught people like you watching this video right now. And if you're serious about this path, I put together a free AI engineering roadmap that lays out exactly what to learn. The link is in the description. But first, let me show you why the odds are so different between these two roles. And here's the key insight for that. You need to understand ML concepts for MLOps, but you don't need to implement algorithms from scratch. You need to know what a model does, but not how to build one from pure math. And here's the hard truth about what each role does day to day. ML engineers often build, train, and optimize machine learning models. They are experimenting with architectures, tuning hyperparameters, and analyzing why a model is underperforming. The skills required to go deep really do rely a lot on mathematics like linear algebra and probability theory, and these are things that you cannot fake in an interview after just 1 month of practice. MLOps engineers, on the other hand, take those models and make them work in the real world for deployment, monitoring, scaling, and automation. If the ML engineer builds the brain, the MLOps engineer kind of keeps it alive in production. And the skills here are systems engineering, things like containers, orchestration, and cloud infrastructure. Basically the same skills that power the DevOps evolution. And the tools these two roles use tell the whole story. ML engineers live in PyTorch, TensorFlow, scikit-learn. Among Python developers doing ML work, scikit-learn still leads at 68% adoption, followed by PyTorch and TensorFlow. Now, learning PyTorch syntax maybe takes 2 weeks. You can follow a YouTube tutorial and have a working neural network by dinner. But the problem is that you won't really understand why it works, or more importantly, why it doesn't work when you change just one single parameter. That understanding comes from years of studying ML theory, not weeks of tutorials. MLOps engineers live in Docker, Kubernetes, Terraform, and Airflow. In Kubernetes-focused infrastructure roles, Docker appears in 59% of job listings, and here's the key difference between these two. Every single one of those machine learning operations tools was meant to be learned. Kubernetes and Terraform can be self-taught, and DevOps engineers are where a lot of self-taught engineers are coming from. Now, the salaries for these two roles are actually competitive either way. Entry pay can be quite similar when senior roles can hit up to $200,000. And in elite roles, you can even see hundreds of thousands of extra pay on top of that. But that's a cool story in theory. However, what really matters more than the salary ceiling is what your actual odds are of reaching a good salary. And if you consider this, then if you self-teach ML engineering and spend 2 years learning, you might apply for 200 jobs and get 0 offers because you are still competing with people with credentials that you cannot match. If you self-teach MLOps, you're competing on a much more ground level. Your projects might matter more than your degree in some cases, and the market backs this up. The MLOps market was valued at $2 billion in 2024 and is projected to reach $16 billion by 2030, and some analysts project even higher growth, but We never know for sure, right? Now, in any case, that's a real demand with not enough people that are qualified to fill it. So let me give you the honest assessment based on where you are starting from. If you are currently a software engineer or DevOps engineer, MLOps is a pretty obvious choice because you already have a lot of the skills like Docker, CI/CD, and cloud platforms, or you can learn it very quickly and just add the ML specific tooling on top of it. If you're self-taught with no machine learning background, MLOps is still the more realistic path because you can enter through DevOps first and then add ML knowledge. It doesn't have to be a direct path. By going this route, you don't need to understand neural network mathematics, you simply need to understand how to deploy and monitor systems, which, to be fair, can be hard enough already, but you can learn this on your own. If you genuinely love mathematics, if optimization problems excite you, then perhaps ML engineering is worth this uphill battle. But if you're being practical and you want to maximize your odds of landing a job in AI within the next year or so, then MLOps is the safer bet. Here's a final point about future-proofing. As AI gets more powerful, MLOps gets new branches like large language models instead of other ML models. And now you will learn new concepts like prompt versioning, RAG pipelines, and how to monitor and scale vector databases. The vector database market alone has grown to 1.7 billion in 2024 and is projected to reach 10 billion by 2032. And this is a completely new market. LangChain, one of the LLM orchestration frameworks that sees a lot of usage, has over 90 million monthly downloads. And when you want to use these kinds of frameworks in production, well, it can be quite complex. The complexity is increasing and not decreasing. The skills that you will build as an MLOps engineer will become more valuable as AI grows. And this means that you will not be replaced by AI because you're building what AI depends on. So here's what you can do right now. If MLOps sounds like your path, you need to actually start building and not watching more YouTube videos like this one. Check out my free AI engineering roadmap in the description where I break down exactly what to learn so you will not be wasting time on the wrong things. I'll see you there.